titrate.
Acid, 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 base. Acid, 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 base. Acid, 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 base. Got to titrate this on time. Acid, 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 base. Acid, 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 base. Acid, 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 base. Got to titrate this on time.
I'm ready for the lab.
No, you're not. You need an apron.
Also, you need goggles.
And you need to put your hair up.
Also, for lab purposes, those shoes are atrocious.
And are you chewing gum? You need to spit that out.
Also, you're gonna need some of these.
Also, you need adult supervision. Yeah?
The third paper, only a month later.
Closed-toed shoes, aprons, and gloves were worn during the lab to protect exposed flesh from harmful acids and bases and broken glass. Safety goggles were worn to protect the eyes from exposure to harmful chemicals. Also, hair was tied up back into a bun to keep the hair from harmful chemicals. Students were supervised at all times.
Purpose.
The purpose of this lab was to find the unknown concentrations, the pH, the pOH, the amount of hydronium, and the amount of hydroxide in 2 hydrochloric acids and a sulfuric acid.
Hey, what's titration?
Funny you should ask. Titration can be used to determine the unknown concentration by comparing the concentrations of the acid and base. Titration is the controlled addition and measurement of the amount of a solution of known concentration required to react completely with the measured amount of a solution of the unknown concentration.
Whoa! Hey, can you tell me about indicators, pH, equivalence point, and endpoint?
Oh, whoa, that's crazy. In a lab, indicators and pH meters can be used to determine the equivalence point. The equivalence point is the point at which the two solutions used in titration are present in chemically equivalent amounts. Also, the endpoint can be found during titration. Endpoint is the point at which the indicator changes color during titration.
Titration makes me so happy. Tell me more about indicators and neutralization reactions, because I just can't figure it out.
That's such a coinky-dink. An indicator is a compound whose colors are sensitive to pH. The balanced equation for the neutralization reaction is H3O plus aqueous plus OH negative aqueous yields 2H2O liquid. The hydronium and hydroxide are at chemically equivalent amounts.
Obviously. Just like this? I understand everything now. I have to go back to the lab.
Two clean burettes were put in the holder next to each other. The burette used for acid and the burette used for base was decided. This setup was constructed 3 times, once for each acid. The acid burettes were labeled with different colors corresponding to their acids. Acid A was labeled red, acid B yellow, and acid C pink. The base burette was always labeled blue. To clean the burette was filled above the 0 milliliter mark with the acid. Then, the burette was turned on to drain the acid. This was done again with the base burette.
Both burettes were cleaned 3 times.
One burette was filled to a point above 0 milliliters with the acid of unknown concentration. Some of the acid was released from the burette to remove bubbles and lower the volume to the calibrated portion of the burette.
The volume of the acid in the burette was recorded to the nearest 0.01 milliliter as the initial volume.
A Approximately the predetermined volume of acid, 8 milliliters, was allowed to flow into a clean flask.
The initial volume was subtracted from the final reading. It was recorded to the nearest 0.01 milliliter as the volume of acid released into the flask. 3 drops of phenolphthalein was added into the flask.
The other burette was filled with the base above the calibration mark. Some base was removed from the burette to remove air bubbles and to lower the volume to the 0 calibrated mark.
The volume of the base was recorded to the nearest 0.01 milliliter as the initial volume.
The flask was placed under the base burette. The base was slowly released into the flask. The pink color of indicator faded with swirling. When pink color stayed for longer periods of time, the base was then added drop by drop. The equivalence point was reached when a light pink color remained after 30 seconds of swirling.
The initial volume reading was subtracted from the final reading. This was the volume of base released into the flask, recorded to the nearest 0.01 milliliter.
This entire process was done 3 times with acid A, acid B, and acid C.
To find the averages, the sum of all the trials were divided by 3. For acid A, that was 8.00 milliliters. For the base, it was 12.2 milliliters. To find the average number of moles used for the base, the molarity was multiplied by the liters to get 0.0116 moles sodium hydroxide.
Since the ratio of HCl to NaOH is 1:1 in the chemical reaction, we know that the average number of moles in the base is the same as the average number of moles in the acid.
The average molarity for the base was given. The average molarity of the acid was found by dividing the number of moles by the number of liters to find the average molarity of the acid.
The average hydronium was the same as the average molarity, but converted into scientific notation. The average pH was found by taking the negative log of the average hydronium. The average hydroxide was found by dividing 1.0 times 10 to the negative 14 by the average hydronium. And the average pOH was found by taking the negative log of the average hydroxide. The average hydroxide for the base was the same as the average molarity, but converted to scientific notation too. The average pOH was found by taking the negative log of the average hydroxide. The average hydronium was found by dividing 1.0 times 10 to the negative 14th by the average hydroxide. And the average pH was found by taking the negative log of the average hydronium.
These same processes were used for acid B. For acid C, the base calculations were done the same way as before.
The average volume of acid C was found by dividing the sum of the volumes found in each trial by 3 to get 8.00 ml. Since the ratio of H2SO4 and NaOH in the chemical equation was 1:2, the average number of moles of NaOH was divided by 2 to find the average number of moles of H2SO4. To find the average molarity, the average number of moles was divided by the average number of liters. Because of the ratio of 2:1 of H2SO4 and H2O, the average molarity was multiplied by 2 to find the average hydronium.
The average pH was found by taking the negative log of the average hydronium. The average hydroxide was found by dividing 1.0 times 10 to the negative 14th by the average hydronium. And the average pOH was found by taking the negative log of the average hydroxide. After averaging 4 of the groups, the average molarity of acid A was 0.15 moles HCl. The average molarity for acid B was 0.17 moles hydrochloric acid. The average molarity for acid C was 0.036 moles H2SO4. For acid A, our average was very close, only 0.005 off. For acid B, it was a little farther off, being 0.027 off. And for acid C, our average molarity was very off, being 0.0169 off.
Some errors that may have occurred in this experiment are the swirling too long. This was a random error. This would cause too much base to be in the mixture. Another error could be reading from the top of the meniscus instead of the bottom. This was a personal error and may have caused a skew of the results. Another error could have been not reading the burette precisely. This was a systematic error and also may have caused a skew.
I can't believe titration